Hey, hey, hey. Good morning, good morning, good morning. Last stream of the week. Let's see if we can get some things into place. So we're right in the middle of a little bit of a rework. Good morning, Calvino. Of the structure of the data behind the terrain and the terraforming and stuff like that. So this issue. What I want to get done today is I want my debugging tools. So this one, I don't know if it's that visible when we have the water in the way. So let me just remove that one real quick. -1. I want to get these to work today. So it's pretty much just original material. Yo, what's up, Derek? Original material. This one is just a placeholder. Then we have height data, foliage data, water data, and something more. I want to make these work for each of the different datas we have and with this new system. Yeah, that's pretty much it. And yeah, then I want this to work as it used to. But let's see. The biggest problem we will have to solve is how to properly send down this to the GPU and how to use it. So I'm just gonna dive right into it. I ended yesterday's stream by asking myself a question, pretty much, and that is, how exactly do I want to structure this in the shader files? And I like. Let's see here. When we have something like this. We include shader codes from separate files. It makes it a bit more structured, and you only need to change it in one place to change it in the other place. It's pretty basic stuff. But I would like to have, so much like we have reflection HLSL and scene texture HLSL, I would like to have terrain data.HLSL. The problem being that some shaders is only gonna need the base terrain data, some shaders are gonna need the water data, and some shaders are gonna need the activity texture data, pretty much. So we're gonna have to split them up, and I think that's okay. So instead of having, we have terrain data HLSL here. I wonder if let's see, can I do this? Okay. I'm pretty sure that I'm gonna have let's see here, we're probably gonna have a folder with terrain data related stuff. I'm just thinking if I should put it in shader utils or create. Now we're probably going to create a new folder. So I think we're going to do something like this. let's see here. Fuck, I do like the visuals of this though. That's very nice. But okay, I think we're gonna do it like this. Shaders. Let's put it in shader utils actually. Terrain data. And then we're gonna have a file terrain data unpacking, I think we're gonna call it. So that's just going to be an HLSL file that contains all the. It doesn't contain any properties, but it unpacks data, and I'm talking about when we get the data on the GPU, it's packed into 32 bits, but what we want to represent it as is actually 4 different uints, pretty much. As I've understood it, most hardware, so GPU for instance, they definitely like to work with float 32s. That's like the default format. And for some hardware, even if you work with ints in shaders, it's actually 32, or even if you work with halves or whatever, it's actually 32 bits in the back. But by packing 4 bytes into one float, sending it down to the shader and then unpacking it, we minimize the transfer time, and I think that's very, very important. Having high hopes for that shit, to say the least. Okay, so terrain data packing, it's going to contain methods for unpacking and packing data, so from 32 bits to 4 different, so from one 32-bit value to 4 different values, maybe 32 behind the scenes, but we're gonna work with them as bytes pretty much. Yeah, that's another question. We'll get to it. Good morning, Geralt, and happy Friday indeed. And then we're gonna have one called, let me copy this one. We're gonna have one that is called terrain data base, I think. These will probably change eventually, but for now I'm thinking of having it like this. So terrain data base, terrain data water, and terrain data activity. Terrain data base, terrain height, and foliage information, I think. Terrain data water, pretty straightforward. Water amount, water flow, water times, I don't know. But the bottom line is that we have 4 bytes for base, 4 bytes for water, and probably 4 bytes for activity as well. So we're going to start with these 3. Okay, terrain database. And then we can remove this one. Terrain data packing, terrain data water, and terrain data activity. Okay, let's start with packing. It's this one. So structured buffer U into terrain data. We're not going to have this one here. Instead, we're going to have get terrain data by UV, get terrain data by int x and y, get terrain data by index like this. Okay. And then we're going to get help from here. Yes, so it's basically like this. Float for, in fact, do I want to return it as float force? Get terrain data. And then I also we have to decide how we want to work with it on the shader level. I've always imagined it as float values between 0 and 1. I like to work in that normalized way. So instead of having to play around with values between 0 and 255 or something like that, or a float value 1 to 1000, we just have a normalized value 0 and 1. 0 is min, 1 is max. So that's something we're going to have to do here as well. And we're going to do it like this. Let's see here. We're always working with... I haven't really decided this yet. This might change. It will probably change. So if a texture if terrain base, for instance, is just going to be the height values, then it's enough to just store it in 1 byte. So that means that our struct on the CPU is just 1 byte. And we're going to have to handle it here with a real index divided by 4. But for now, we pack it with 4 bytes. So each of our uint is actually 4 different values. Our index here is our real index. So we just need to do... In fact, we probably want to send in the data here as well. Oof. No. Can we send in... Yeah, we should definitely be able to send it in like this. I think. Like this. So it's gonna be... In fact, let's rename this one data buffer. And then we do uint data is equal to data buffer index. So then we get 32 bits as a uint, and then we want to split it up. So we're gonna do it like float 4, or we can do return float 4. And then what is it? First of all, we can do it like this. Data 8 or something like that. Bit shift, and then we want to do this. But we want to keep this one like this. For the first one, we want to do 0. And then we want to bit shift it 8 bits per value, right? Where is it? So 0, 8, A, B. Is it like this we want to do it? But let's dive into this to make sure. Extract 4 bytes from 32-bit. Would like to have a more convert. Yes, JavaScript. Let's see. 24, 16, 8. This is our mask, right? So it's F. Let's be a little bit more specific. I don't care about floats though. One sec, let me also... never mind. Yes, we had an and mask. Yeah, 0, 0. It's not really like that we want to do. One sec. This should probably be it, right? We can double check it, but then again, now we have a u int. Does it make sense? Yeah, I think it does. So this is just, it's still just a u int, but we have quote unquote unpacked. And I want to make it into floats. We know that the values are bytes, so between 0 and 255. So we can probably just divide with 255, right? As this. And that should be it, right? Can we get some information out of this one? Let's see. Do we have some, can we take get dimensions, beautiful. Beautiful. Okay, so it's this one I'm interested in. Just write in bytes of each structure element. Ooh, so we could probably generalize this function such that makes me wonder, however, if oh well. We don't know anything about the dimensions here, so I don't know how much this makes sense. I don't know about this one either. Because it's actually just a list, but when we create it, we think about it as a grid, basically, a matrix. Would like to work with it like such as well. That's why I'm looking for something like this. I don't know how often we're gonna use this, so we might as well do this. And so data buffer float2 size and then UV. So we just do return get terrain data buffer joint index UV dot size.x plus uv.x. But then again, is it something like this we want to do? So let's say it's 128 times 128, uv is between 0 and 1. 0 becomes 0, 0, 0, 0. 1 is I think it's something like this, right? So let's say that we have 128 times 128, we send in UV. Let's see here, I want to get whatever value we have in this pixel, which means that we send in UV. We send in UV5 divided by 120. So 0.03937 and 90 divided by 127. 0.7. So then we do for the X index, we do, and this one is actually also, what is it, 90 times 128 . 90 times 128 plus 5. 0.039 times 120 yeah, it's a question of size 128, 128. So we have 128 values. It's actually size minus 1, right? We're gonna have some fucking mismatch errors here eventually, I think, but something like this. And that's our index, and that's what we return. Packing, and then we can take terrain database, I'm wondering, terrain base data, get terrain, database. Not the best name, but whatever. And here I'm thinking of, we're probably never gonna use this one outside, so we're always gonna go with this one. When it comes to the size of this texture, I wonder if we want to set it, or how we want to set it. I'm still not entirely... I don't want to give up, fully give up on the idea to have different sized textures, which means that terrain data base and terrain data water might not be the same size. It's probably going to be something like terrain data base and terrain data water is the same, but terrain data activity might actually be double the resolution. I haven't really decided on that one. So I wonder if I want to do float 2 terrain database size, get terrain database, get terrain base data, get terrain water data. What the fuck, that's a better name. Terrain data packing. And base, let's see, terrain. And I would just send in a float to UV here, and we return, then we want to include it as well. Geralt, you're doing a great and beautiful work. I really enjoy your streams, sir. Thank you, I appreciate the kind words. Appreciate you being here as well, following along. So here we include, but we don't care about jumping up. So can we just do terrain data packing HLSL? I don't know if we need this one or not. And here we return get terrain data, terrain database. Want to rename this one as well. Base data, terrain base data. Terrain base data size, and then UV. So in our shaders later on, if we have a shader that wants to use the base data, we just do include terrain base data, and then we call get terrain base data with a UV. And hopefully, in the end, we don't have to, we can implement this one once and this one once and then just forget about it. But we will see. So I want to try this one. Right now, I think our base data is terrain data type. Our base data is height, foliage, unused 1B, unused 1A. Okay. Let's try this one. So I want to try this with these ones. So, and this one is terrain debug shader. So what do we have here? Include shader utils, terrain data, terrain base data.hlsl. Terrain data texture, point clamp, texture resolution. Yeah, we're still gonna need these, unfortunately. These three, actually. Yeah, probably want to hide these here as well. So terrain base data size. Is it a float too? Just float. Terrain base data. UV scale, terrain base data UV offset. This is probably something we're gonna make. I think we can fix this quite nicely. We'll see. So get terrain database with the UV here. We also want to do float to UV. UV times terrain database UV scale plus terrain database UV offset. Something like this. So I want to remove all of this from here. So this is where we, let's see, ground color, none. Terrain data UV, we don't need to do that. Terrain data. So instead of doing terrain data sample here, we do get terrain base data, and we just send in input.uv. Oh, fuck me, we needed to calculate the grid. Weird that we don't scale it here. We can probably do it like this. Logsage, what's up? You code everything, you don't use the UI for shaders, etc. So I guess you're talking about Shader Graph. I used to do a lot of stuff in Shader Graph, but I'm still on Unity 21.2 and they didn't really have everything I needed for my weird ass shaders. So moved back to pure HLSL, yes. Okay, how do I want to handle this the best way possibly? We can probably do... Themu, what's up, what's up? I just want to hide this stuff, basically. I find it a little bit weird that we don't scale it here when we calculate grid value. I'm gonna try, let's see here. I think we're gonna do it like this. Do I care about having those here? No, I don't. Actually, let's do it like this. Terrain debug shader, grid. Yeah, we're gonna have to do if else here as well. View distance. Then we started to learn Unity in 2020. I've never touched shaders. How complicated is it? It's pretty complicated. It's a little bit of a different way of thinking compared to the usual programming you do on CPU. Shader Graph helps a lot though. Shader Graph really makes it much easier. Okay, I think we're gonna do it like this. View distance, we just do this one because this damn grid. Let's do view distance we can keep here. Grid alpha we can keep. We're gonna do it like this. We do grid alpha like this. Grid color. Yeah, whatever. We move this one down to here as well, because this one is going to be specific to do float 3 grid position is equal to Oops. Yes, we're gonna have to do this and this for each of the different data we want to show. So basically here, if we have height, we're gonna do terrain base data size.x offset terrain base data uv offset.x. .y, and here I think we're just gonna take the first one, so terrain base data size.x. Terrain data base, yeah, base data. Interesting. Yeah, I want to do grid alpha here. We want to do grid times this one as well. We get purely black here because we haven't sent in terrain base data. We haven't sent this information to the GPU just yet. So we're gonna have to quit this one and do that. And I want to do it in a nice way. It's probably gonna be terrain base generate terrain material, water material. This is where we set all of this shit. I don't think I want to set this here. But the bug material, here we set material, terrain patch set material. This one, we're going to make this a little bit more complicated. When we set a material here, we want to figure out in some way we want to communicate what data does this material need. But then again, set material texture. I think we're gonna skip this one as well. generate terrain data. So, terrain patches has terrain patch mesh, and that's the mesh that's being rendered, and it's that one we want to change the material on. Mesh filter, mesh renderer. I wonder if I can clean this up in a nice way. Or actually, now when I think about it, for now I think we're gonna do this. Set material texture. Let's do it like this. Generate terrain data. These are old, working with the old system, so I think we're just gonna remove those. Set material texture, we're gonna skip that one as I want to rework this one as well. This one is used for when we want to add weather data. That's another thing actually. When we want to add weather data to the GPU, or we want to send weather data to the GPU, we send it as a texture currently. Possibly rework. Removing the need for texture. I haven't really decided just yet how we want to handle this one. But anyway, this one, set material. Here I think we're gonna do it like this. Can I get params? Params terrain data type. It's like this, right? Material terrain data type dependencies. And then we do this for if material terrain dependencies dot length is bigger than 0 for each terrain data type material terrain data type dependency in a little bit too long names here, but we can probably make it a little bit shorter like this. So for each one of these, we're going to do something like material.set. We're going to set buffer. We're going to set buffer, we're going to set vector, 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 okay? So it's going to look like, but to get those values, we need to get them from somewhere. And I'm thinking of having it in terrain data. No, not terrain data, but terrain data buffer. Probably want to put this one in its own file soon. We also have terrain data type. Is it here I want to define the constants? Public, private, static, string, terrain data buffer names. Terrain base data. Terrain base data. And also, can I do it like this? Do we just want to do it like this? Terrain base data, terrain water data. Private static string. I'm not too sure about this one. We will probably change this a lot as well. Derek, how goes the progress, Robin? Got a little busy with work. I think we're moving forward. Pretty smoothly so far. A lot of boring stuff, but yeah. Terrain data buffer size names. So we want one like this. We want private static string terrain data UV scale names. private static string terrain data UV offset names. Not too sure about this one. Buffer name, return terrain buffer names, type dot buffer index. Public static string buffer size name, buffer UV scale name, can probably clean this up eventually. Terrain data type, terrain data. Okay, so terrain data buffer. I wonder terrain patch data. It's a little bit of a, I wouldn't say mismatch, but I don't like here. We have terrain patch. Terrain patch has terrain patch meshes and terrain patch data. Probably want to clean that up eventually. But let's see here. How do I want this communication to happen? Do I want to send the material down to this one, or do I want to be able to access these ones from the outside? Ugh. I'm wondering about this one as well. This might just be a terrain patch. We might as well put this one in here, make it a little bit easier to work with. But for now, let's do it like this. Terrain patch data. Yeah, we're gonna do it like terrain. Set data in material. For each terrain data type dependency in this one. Oh. Really? interesting. But that's okay. We don't need data. Public get private set update buffer. Okay. Set data in material. So what we want to do here is material.set buffer. Now we have name. So we do. Let's keep it short. Type dot buffer name. Buffer type dot compute buffer. Material dot set buffer dot set vector. Length public float vector 2, size, width, height, public vector 2 UV scale. Terrain mesh grid delta shader property delta. Mesh grid delta, mesh grid offset. In fact, do we care about those? Whatever, it's these I'm interested in. Resolution subdivided -1 divided by resolution subdivided. So that is the UV scale, and then UV offset is 0.5, resolution subdivided. Beautiful. So vector 2, we're just gonna call it scale, is equal to resolution. Yeah, pretty much assuming that they are the same size in this case, but we're not in the future. So new vector 2 float width -1 divided by width, and float height -1 divided by height. And then we have offset. New vector 2 0.5 f times new vector 2 1.0 f divided by width, 1.0 f divided by height. Length, size, scale, offset in terrain data buffer. Okay. So then we have set vector dot type dot something name, buffer size name, buffer type dot size, material dot set vector type dot buffer UV scale name, scale. So this is something, set data in material. This is pretty much something we're just going to call on instantiation. So when we start the game or when we load the file, when we open up a garden, this is where everything is going to be set. It's probably going to be, in the end, it's going to be pretty static always. With that in mind, we might be able to make this a little bit nicer in the future, but type dot UV offset name, buffer type offset, and there we go. Right. So we do that for all the dependencies it has. The type will decide which buffers are set, and so on and so on. Set data in material. So in terrain patch, set material texture, or set material there, and here we do terrain patch data. The more I use this, the more I just wanna terrain data, merge patch data and patch together. I think we're eventually gonna do that. Data dot set data in material terrain data type dependencies. Oh, it's just terrain data. Set data in material, and then we want to set it on the correct. So ground mesh, we're going to use this one right now. Set material. Let's try it. Let's see what we get. Do we have any errors? Oh yeah, we don't have any generate terrain data. Terrain patches generate noise scale. I don't care about this right now. The system for either generating the initial data or loading the initial data from file has changed quite a lot. A native collection has been disposed. Yeah, we definitely need to fix that as well. Let's do that real quick. Terrain patch data. Yes, I definitely want to remove this one. Just take the just take some of this functionality and put in terrain patch, I think. Eventually. But let's see here. Terrain patch data. This one has terrain data buffers, terrain patch. Do we have on destroy? No, we don't. I don't know, do we need to clear compute buffers as well? Now it's mostly native array. Dispose. Mm-hmm. Okay, so what do we have now? Terrain base. Let's just play, see what happens. Hopefully nothing crashes. Close to. Nej. Oh. do I do? Terrain material. Okay, let's pause. Object reference not set to instance of an object. Environment. Terrain material. Okay, so what is it? Terrain patch. Environment controller. Terrain patch 159. The rig is all reworking just to be more scalable, or will it also improve performance? Yeah, I think this is one of those nice reworks where we get both performance, scalability and extendability. So this is going to be better all around pretty much. Okay, so I'm guessing here that it's our terrain data that is a problem. Instantiate terrain data. Yeah, we don't instantiate terrain data here, right? So instantiate here. Terrain data is equal to new terrain patch data. Resolution. And then we instantiate the data. Okay, let's try this. Oh yeah, we need to double check one thing. Never mind. Okay. Terrain, grass, undeclared, identify grid. Of course. Okay, let's see. Two problems with this one. We don't get any grids. I would love to get the grids first of all. Calculate grid value, util helper functions. Okay. Don't we set these accordingly? Why don't we get a grid here? Yo, what's up, Fabic? Let me just try return float 4 input.uv x input.uv.y 0 1. This one works. Return terrain data texture resolution. Can train data size be 0? It shouldn't be. Mm-hmm. I've relied on this one so many times, so I don't think that's one is wrong. But why? What do we change here such that could be this one? 128. Yes. Yeah, and we don't have any offset either. Okay. So I think this one is 0 probably. So you're probably on to something, Fabic, but it shouldn't be. Let's see here. But terrain base. Set debug mode, material, terrain material. Okay, here. Disable enable keywords, and then we do material, and then for each terrain patch set material. But we don't send in, fuck yeah, we don't send in terrain data type dependencies, so we never add any data to it. So set material. It depends on debug terrain mode, non-grid height, grass water gradient. Debug terrain mode, why? Yeah, we can probably remove this one and just add get shaded keyword name. Oh, we can do it like this. Yo, what's up, Dev Spires? Thank you for the raid, and you too. Appreciate it. And have a great weekend as well. Grid none, height. The only reason I pack it like this is because gradient? What do we show on gradient? What the fuck? I don't even know what that one is supposed to be, but something like this. The only reason I have debug terrain mode is because I don't want to have this one littering the terrain data type, but fucking hell, might as well. But so terrain base, what we need to do here is, yeah, for now we're gonna do set material, and then here we send in debug terrain mode dot get terrain data type. So we tell the terrain patch, hey, use this material right now, and you need to get this data. Let's see if this works. Yeah, I guess we're gonna have to double check that one eventually. Very low FPS this time around for some reason. Oh well. Index was outside bounds of the array. It's like we don't have any data, that's weird. Instantiate terrain data, new terrain patch data. buffer name. Is it this one that fails? Buffer index. Terrain data buffer names. We create them here. Timestamp 7. Buff. Oh! Interesting. Could it be because of none? Probably. But that should be on shift 1, shift 2 works. Okay. Good. Okay, nice. So now we probably get the correct one here. Let's double check it. Scene. Almost. Not really. So these values are a little bit wrong. I wonder why. No, one sec. This looks fucking beautiful. This is exactly what we want. So each vertex is located, maybe. Each vertex is located in the middle of one of these squares. That's good. Okay, nice. So pretty much when we read a value for this vertex, we read it in the middle of the pixel. I wonder why it didn't work initially. I think we're ready to do the next step, but I want to try, let's see here. Let's unplay this and remove we get an issue on debug terrain mode none. No, not none actually. But when we do mode we never want to return none here because let's just return height. Let's see if this works. Okay, shift 2, 3, yes. That looks pretty damn nice. Debug shader, we want to do this, the same thing here. Okay. So this is our grass data, this is our height data, this is nothing, this is just some ugly grid, and this is the original. We currently get full grass because of how we read the data. Let me try this. Let's pause this one, go to terrain. Procedural terrain procedural grass. This is where I want to nullify it as well. Fabik, you're doing great, Robin. Keep it up. Thank you. Appreciate it. Do we have it in somewhere else? Terrain data G should be 0. What the fuck? Why are we getting green here? Terrain data 0, 0, 0. We do it here 0, 0, 0. Interesting. Have I changed something else? Whoa, 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 whoa. Fuck, we read it in 4 places. Probably want to avoid that eventually. That's for sure. Okay, there we go. Now it represents what we have here. So let's try and do this. Let's add some foliage here. Just add a little bit. But we don't get any change here. Okay, so first I want to try to do, when we generate the data, terrain data I want to do oh, yes, we never called this one. So we do, we can try that first. Terrain patch, alter terrain data blit. We do all of this, but in the end we also need to do buffer dot isn't it called apply? Update buffer. Okay, let's see if we get a change now. So we pretty much just changed it on the CPU, never sent it to the GPU. Let's see if we send it the correct way this time around. No, we don't. Okay. I'm thinking that this might actually be wrong, so I want to try and do, I want to generate some values here and see if we get the correct values to the GPU. Set value public void generate values int value index, and then we call it I data value generator. And let's try and generate it with a Perlin noise data value generator. We want to generate value here with U and V. Generate byte value. For int I is equal to 0, I is less than data dot length I plus plus, and then we do set value index I, and then the value in question, generator dot generate byte value, then we float U and V. So we want to transform a linear or one-dimensional index to a two-dimensional, and we also want to bring it from 0 to size. So what is it? It's, we can do float to UV. No. Let's do it like this. So X is I divided by size X. Is it? I've done this so many times now, I should know this by heart. So if we have a 10 times 10, we have an index of 13. Our X should be no, that's not it. No. Right. Okay, let's start with one-dimensional to two-dimensional. I module size x, 0, 1, yeah, and then when we get to 10, we return 0, and that's good. And y should be I divided by size y, right? Zero. That's how we want to do it, right? And then we want to cast this to... we can cast divided by float size dot x minus 1 divided by float size dot y minus 1, right? Generate values. Let's just assume this is correct. So let's jump back to terrain patch data, wherever we instantiate. So terrain patch, or actually terrain patch, generate data, implement. Okay. And here we do buffer type dot generate values. Value index is type dot data index and generator. So then in terrain patch, when we instantiate stuff, or here rather. UV offset, UV scale. And we should hopefully see some data being sent to the GPU now. So not purely zero values, but actually something we can use. But we don't get it. We generate it, but then we don't apply it. So if we do... Okay. And we can see here that my indexing is definitely wrong. Yeah, this one is fucked. Or is it? UV offset, UV scale, noise scale. Yeah, we shouldn't need to cast this either because we package it in a vector 2. I don't see what's wrong with this one. Fabric put values instead of this size variable. Yeah, we can try that. Resolution. It's pretty apparent from the visuals here that it's a problem in one direction. Let's pause this. Let's do environment resolution 256. Is it the X that is getting screwed up? No, it's... yeah. It could actually also be... okay, let's test this again. It could also be when we read the value. Ooh. It could be... what the hell? Shift. It could also be the way we read the value in the shaders. So terrain debug, we do grid, then we read grass, terrain data G, terrain data get terrain base data. So this one, it might actually be this one. UV times terrain base data UV scale, terrain base data UV offset, and then could be this one. So when we go the other way around, make it into a two-dimensional index. No, if we have a two-dimensional index, we make it into a one-dimensional index. UV times, we send in terrain base data size. Yes. UVX, it's a float. We do it multiply. If it's 1, we want 127 or 255. Okay, so let's do it like this. Just take it slow and easy. Float 2. We change the normalized UV between 0 and 1 to the actual size. So for x, that's uv.x times size.x. And for y, that's uvy times size.y. And then we want to transform it to a single index. And that should be index.y times size.x plus index.x, right? We want to do -1 here as well. Or do we? Yeah, we do. So that's what we do here. Now we multiply with this. We maybe don't want -1 here. But I don't think that's enough for it to... This also looks correct. To me. No. Or does it? It could be, it can be the generation doing it wrong, but I don't think so. We have tested this one thoroughly. It could be this one, this conversion, or it could be this conversion. It could also be this, but I don't think so. Let's try and do terrain debug shader. Let's skip doing, let's just send in UV as is. Same problem. I don't see how this one is wrong. don't see how this is wrong. UVs we've already tested. UV offset, this one we set to 0. UV scale is 1. Noise scale is 10. It doesn't matter if it's this one that is float or this one, right? Do I instantiate data new native array terrain with height? This one should get it. Do we need to set terrain data dot size, we return 4. Yes, we created the correct way here as well. Compute buffer 4 bytes. This one is wrong, right? But if we want to do width first, but I don't think we use this one, so that doesn't really matter. Compute buffer set data. Zero, 1, 2. It's pretty much like we get the same value independent of X or independent of Y. Independent of X or independent of Y. One sec. Coordinates, UV scale, noise scale. I don't know. Am Am I gonna have to print some values here to get to the bottom of this? Index. It could very well be, let's see here, terrain data packing size here. Fabric, make a patch of size 1 by 1 and print the coordinates. Yeah, we're probably gonna have to do something like that, but let's see here. Size, the size we send in here is terrain-based data size. Terrain-based data size, we should set this one in terrain patch data. It's this one, we set size here. Ooh. Set vector to buffer size name. So many conversions you're doing, it's hard to tell. Yes, indeed. Unfortunately, we pretty much have to if we want to work with it like this. Buffer size name. Terrain-based data size. Okay, that's good. Flow 2, flow 2, flow 2. So that's not a problem. Unless flow 2 here as well. I'm gonna have to get to the bottom of this on Monday. Not looking forward to it, but yeah, we're probably gonna go back, do some basic tests, just see whether the conversion is wrong. Yeah, unfortunately, this is how we're gonna do it. But yeah, I know. I gotta run now. So only 3-hour streams this week. Hopefully, most likely, I will be able to stream at least 1 hour more next week. Still happy with the progress today. I think it went pretty nice. Have a great weekend, everybody. I know I am. I'm gonna do a lot of research, among other things. But yeah, thank you so much for watching. Peace.